In this video, we are going to find the derivative of this 12 questions and including one MCQ over here. And I can see that these two questions are very similar, so I'll be solving one of them, including questions of proving. So let's begin with the first one. The question here is to differentiate with respect to x. First of all, we are going to differentiate this with respect to x. And then we'll also be finding dy by dx at x is equal to a. So let's figure with the first part over here. Differentiating this with respect to x, so y will be dy by dx. What's the differentiation of a raised to the power x? It is a raised to the power x log a. And for differentiating e raised to the power x, e raised to the power x differentiation is e raised to the power x only. For x raised to the power a, you have to recall this is actually in the form of x raised to the power n form, which can be written as n x raised to the power n minus 1. So we'll be writing here n, which is a over here a x raised to the power a minus 1 plus. Next is log x. Log x differentiation is 1 over x. So it is 1 over x. Now this is the first part, but then we also have to find out dy by dx at x is equal to a. So we are going to replace wherever there is x with a. So we are replacing x. So this x will become a. So it's a raised to the power a log a plus this will become e raised to the power a plus this is a dot, this is a raised to the power a minus 1 plus 1 over a. Now check over here, we can apply the laws of exponent and we can replace this with what? This will become 1 power, right? So same basis multiply, power added 1 plus a minus 1 is 1. So rest is going to be as it is. That is, this is a raised to the power a log a plus e raised to the power x, and this is 1 by a. This is how we will differentiate this question. In this question, we are given y as this, and we have to prove that under root x square minus 1 into dy by dx is 1/2 of y. So clearly we are going to differentiate this with respect to x. Now differentiating this with respect to x, this is dy by dx. And what's the differentiation of root x? It's 1 over 2 root x. So it's 1 over 2 root x. This is x. And by chain rule, the differentiation of this is 1. So 1 multiplied is same. Similarly, this is going to be 1 over 2 times under root x minus 1. Now next, what we can do is to take half common and take LCM. So if I take half common and if I take LCM inside, that is, it will give you root x plus 1 multiplied by root x minus 1. So this result to give you root x minus 1 and plus root x plus 1. Now what I can see that we need this on the left hand side, which can be obtained from this. So let's say if I obtain this, this is dy over dx. This is dy over dx is equal to half. One more thing to observe, we need a y over here and this is equal to y. Let me show you that this can be replaced with y only, right? This can be replaced with y. As you can see, y is this only. So I can simply place y over here and below in the denominator is what? Product of this, which is applying a plus b into a minus b is a square minus b square. So we'll be writing this as whole under root x square minus 1. So one more step, I'm going to transpose this to the left hand side. This is what? Under root x square minus 1 is equal to half times y. Oh, there is a dy by dx which I missed. This is on transposing to the left hand side. It will be multiplied with dy by dx and then half times y. This is how we will prove it. In the next question, we have y as this, and we have to prove this. So clearly we'll be finding its derivative. So let's say if I differentiate both sides with respect to x, so dy by dx, differentiation of 1 is what? 0. For constant, it is 0. So I'll place 0 over here plus This is 1 factorial, which is 1. So this is x divided by 1 is x only, and x differentiation is 1. Differentiation of x. Next, this is x squared by 2. So what I can write this as? I can write x squared as what? 2x over 2, right? Because 2 factorial is 2. And likewise, for the next, the differentiation of x cube is what? 3x squared. So this is 3x squared. And for 3 factorial, I can write 3 into 2 factorial. And let's say if I place one more in order to understand, the next in the sequence will be what? X raised to the power 4, right? And that divided by 4 factorial. So its differentiations would give you what? 4x cube. And using this formula, right? X raised to the power n differentiation is n, x raised to the power n minus 1. And 4 factorial in the denominator can be written as what? 4 multiplied by 3 factorial. So we'll place dot dot dot, and for the last part, this is x raised to the power n differentiation. Yeah, from here it can be clear that this is n x raised to the power n minus 1, and n factorial can be written as n multiplied by n minus 1 whole factorial. This we got as dy by dx. Now we can reduce this. I can see that this can be cancelled over here. So if I reduce this get cancelled, this and this. Let me write down what we are left with. So if I write dy by dx is equal to, we are left with 1 plus x, right, plus x square over 2 factorial, right, plus x raised to the power 3 over 3 factorial. And if I keep on writing, right, we have this. So this is x raised to the power n minus 1 over n minus 1, the whole factorial. Now, when you look into the two proof, we need dy by dx minus y. And why is this, right? Why is this? So you can see that in order to get this as y, small changes we can make? We can write this as 1 factorial. And in addition to this, we need one more term, that is this one, right? This one we need. So I can write over here, that is x raised to the power. Well, we need to add it on both sides, right? We cannot do this. So let's say I'm going to add this thing on both sides. So on the left hand side, I'm adding x raised to the power n over n factorial, right, on the left hand side. And so I'm doing on the right hand side, x raised to the power n over n factorial. This we are doing why? To obtain this as y. So you can see this is nothing but, not this one, sorry, this whole as y. So now if I transpose this as y, replacing this is y, I can do directly, this is dy by dx. You may do by replacing this with y and transposing this to the left hand side, it is minus y plus copying this x raised to the power n over n factorial should result to give you 1. So this is how we will do this question. The question says if y equals x over x plus 2, and we have to prove x multiplied by dy by dx is equal to 1 minus y into y. So let's begin with differentiating first. Differentiating both sides with respect to x clearly is going to apply quotient rule. X differentiation is 1 and u dash v is this, right? And then we'll place a minus sign. This time u is as it is, and differentiation of x plus 2 will be x, will be 1, sorry. And this is because the differentiation of 2 is 0. That whole divided by x plus 2 whole square. Now we can simplify by cancelling this x, right? This is actually this x can be cancelled, positive x and negative x. So we are left with what? This is 2 over x plus 2 whole square. Now when I see the RHS over here, we are not near it. Moreover, if I replace, now let's multiply by x. As for the question, you can see there is an x both sides. So if I multiply x both sides, we are going to get this. But still it is not equal to the RHS. In such a case, we should expand the RHS. So what is RHS? RHS is 1 minus y into y. So this is 1 over here, minus y can be replaced with y is x over x plus 2 and then another y multiplied, so it's x over x plus 2. So if I take LCM, it's going to be x plus 2 minus x, that divided by x plus 2, and this side it is x into x plus 2. Right, same as the what we got. This is what we are left with, 2x in the numerator, whole of it, and this is x plus 2 in the denominator. So now you can see that the LHS is equal to RHS, right? So you can see on expanding LHS we got this, and RHS is this. So LHS is equal to RHS. Right, this is, we got it, right? Here in this question, we are given y as this, and we have to prove y multiplied by dy by dx minus x equals 0. So clearly we will be differentiating here both sides with respect to x. It's going to give you dy by dx. And root x differentiation is what? 1 over 2 root x. 1 over 2 root x. And x is this whole thing, right? Keep in mind that this is x. Now, therefore, by chain rule, we also need to find the differentiation of this. So it's going to be what? This will give you 2x plus 0, right? Because x square differentiation is 2x, and a being constant, a square will be 0. Now we can cancel this here. And now if I see that what we need in to prove, we need a y over here. Yeah, this can be replaced with y. This whole thing can be replaced with y. As you can see, y is this only. So that seems to be easy. So if I write dy by dx, and this is, as I said, this can be replaced with y, and this is multiplied x. So if I transpose y to the left hand side, so y multiplied by dy by dx is equal to x. One more step where we'll be transposing x to the left hand side, so it should be minus x equals 0. So here we are given x, y is equals 4, and we have to prove x multiplied by dy by dx plus y square is equal to 3y. So first of all, we'll differentiate this, and for differentiating this, we are going to apply the product rule. So u, which is x here, x differentiation is 1 into y plus x, and differentiation of y is dy by dx. And on the other side, we have 4, and the 4 is a constant, so its differentiation is 0. So we can see from here that we can get dy by dx as minus y over x. Next, we are going to place these values in the LHS. So LHS is what? X multiplied by dy over dx plus y square. So if I replace this dy by dx with this, we are getting what? Minus y over x plus, this is y square only. So x multiplied by this is what? Minus y only, because x and x will get cancelled. And when x multiplied by this, so what I'm going to write? I'm writing xy square. Now, when I see the RHS, we need 3y, right? We need a y, and y is actually xy. Okay, so what we are going to do in the next step? So this is minus y. I'm going to write this as xy into y. This is because I can replace this xy over here. I can replace this xy with 4, right? So that results to give you what? Minus y. And this is 4 times y, right? This is replaced by 4. So this is 3y, and that is equal to the RHS. This is equal to the RHS. In the next question, it says if we have y as this, and what we need to prove as this, that is 1 minus x square. And this is actually dy by dx only. Right? This is what we need to prove over here. So let's say begin with differentiating both sides with respect to x. As I said, y1 is same as dy by dx. So now before that, you should know that differentiation of root x is what? 1 by 2 root x, right? This can be understood like this also, half multiplied by the reciprocal of this, right? So I can say that considering this thing as inside as x, so if it is root x, its differentiation is what? Half root, right? Reciprocal of this. So reciprocal of this is what? The numerator will now become the denominator, and denominator should become the numerator. And then we have to apply the quotient rule also. So to apply the quotient rule, we'll first find the differentiation of the numerator, which is minus 1. That multiplied by the denominator, that is 1 plus x. There's a minus sign in between. Now we'll get the differentiation of the denominator, which is what? 1. And that multiplied by numerator, which is 1 minus x. And then this whole divided by 1 plus x, 1 plus x whole square. So let's simplify it further. We have dy by dx is equal to half under root 1 plus x over under root 1 minus x. This can be simplified further. I can say this is minus 1 minus x minus 1 plus x, that whole divided by 1 plus x whole square. Here minus x plus x get cancelled. So what we have now, dy by dx is equal to, this is half, and this is 1 plus root x over 1 minus x, and this is what? Minus 2, that multiplied by 1 plus x the whole square. Yes, this 2 and 2 get cancelled. So we are left with dy by dx is equal to, this is 1 plus x under root 1 minus x. We'll put the minus sign here, and this is 1 over 1 plus x whole square. Now when we see the 2 proof, let me show you the 2 proof once again. I should write it over here again, the 2 proof. This was the 2 proof. But you can see that we need 1 minus x square along with dy by dx. So what we are going to do is to multiply by this both side. So on the left hand side, if I multiply, we'll get 1 minus x square with dy by dx. And on the right hand side, there's a minus. And what I'm going to do is to write this in exponential form, as we are going to use some laws of exponents. And this is 1 over 1 plus x whole square. So now we multiplied on the left hand side, and we are going to multiply on the right hand side, which I can write as 1 minus x into 1 plus x. This I did, right? This is 1 minus x square multiplied on the left hand side, and this is on the right hand side also. Now let's simplify it. First of all, I'll write down this. We have obtained the LHS, so no need to bring any changes on this side. See over here, you can see that we are going to apply the laws of exponents between this term 1 plus x and between this term and this one. Right. So what you can observe, this is in the numerator, this is 1 half and 1. That is 1 and half, and denominator it is 2. So I can write this as what? It can be written as 1 plus x raised to the power half power, applying the laws. And between the remaining two, that means from this and this, writing this has 1 power, this is half power, same basis divided, power subtracted. So the numerator power will be what? Numerator power should be 1 minus x raised to the power half. Right. So now next is what? We'll just write this in square root. So can I write this as 1 minus x over 1 plus x whole under root, which I can replace with y and transpose it on the left hand side to get the result. So let me do it over here. This is 1 minus x square dy by dx, and there's a minus, right, which I missed. So this is equal to minus y, and if I write minus y on the left hand side, it's become what? Plus y equals 0. So that's how we will do this question. Now in this question, we have y as this, and we have to prove y dash, that is dy by dx, as this. So let's differentiate it first. Differentiating this with respect to x, this is dy by dx. Now you can see there is a power n over here, right? So considering this to be, say, x, and applying this nx raised to the power n minus 1. So we'll get what? N, right? This is n. and x is this whole quantity, x plus whole under root x square plus a square, and that raised to the power n minus 1. Now we are going to do the next thing is to apply the chain rule for the differentiation of this. So x derivative is what? X derivative is 1 plus, and the derivative of this, that is under root x square plus a square, should give you what? 1 over 2 under root x square plus a square. And then finally to get the square root of the inside one, inside the root, which will result to give you how much? 2x only, because a is a constant, its derivative is 0. Right, we have this 2 get cancelled. Now next is to simplify this. This is dy by dx is equal to n x plus whole under root x square plus a square whole power n minus 1. And on this part, if I take LCM, LCM is going to be what? X square plus a square, and 1 multiplied by this is same, that is x square plus a square plus x. Now look into the to prove part. To prove part, we need this over here. I can see, but we need a y. Okay, I can see that y can be obtained from these two. So let's say if you can see that this when multiplied, this when multiplied by this, they are same, right? It's just the order in which they are written are different. So applying laws of exponent. So if I write the LHS as dy by dx, I wrote this as n. Let me once again show you that we are going to simplify this and this. So we know that when same bases are multiplied, powers are added. So I can say that this is x under root x square plus a square. This plus 1 is n only, right? So power n. And then this whole divided by under root x square plus a square. Yeah, this is what we need. In fact, I can replace this thing with y, right? This can be replaced with y. So let's say if I do it here only, we have dy by dx equals n, and this can be replaced with y. So it is ny, and below we have x square plus a square. That's how we prove this question. So we are given y as this, and we have to prove this, right? 2xy, 2xy divided by dx as this. So you can see that we can simplify the working of this to prove if we do squaring both sides. Now let's understand why I'm saying so. On squaring left hand side, this is y square. Square of this is what? Applying a plus b whole square. This will be without the root. Square of this is what? A over x plus 2 times ab, and what is a? A is this and b is this within a single root. Even this get cancelled. Now if I find differentiation of this, so y square differentiation is 2y and then dy by dx. Differentiation of this is what? X differentiation is 1, so it's 1 by a, and 1 by x, the differentiation of 1 by x you should know. Actually 1 by x is like this, so minus 1 x raised to the power minus 2, it's minus 1 over x square. So we can directly write this as minus 1 over x square, but a is there, so it should be like this. And differentiation of this is constant. This is a constant, right? So its differentiation is 0. When we look into the left hand side of 2 proof, we need an x over here. So let's multiply with x both sides. So it's going to be 2xy dy by dx is equal to multiplying x over here is x by a, and multiplying x over here, 1x will get cancelled with the x multiplied. So it will be a over x. Right. Yeah, that's what the RHS, right? We got the RHS. This is what we need to prove. Now in this question, we are given y as this, and we have to find dy by dx, and this is an MCQ. So let's say if I write finding its differentiation, right? The differentiation of 1 is 0. So I don't write, I will not write it. And differentiation of x is 1 plus differentiation of x square, right? So x square differentiation is what? 2x, and 2 factorial is 2, plus the differentiation of x cube. So x cube differentiation is 3x square, and this 3 factorial can be written as 3 into 2 factorial, and so on. Like I need to write one more term. Let's say this is x raised to the power 4 over 4 factorial in the progression of this. So it's going to be 4x raised to the power 3, and 4 factorial can be written as 4 into 3 factorial. And if you keep on doing so till the end terms. Now we have to find dy by dx and choose the answer. So let's say if I reduce this, so what we are getting, let's say this is 1. Can I write this as x can be written as x over 1 factorial, because 1 is 1 factorial. This is x square over 2 factorial, and this is x cube over 3 factorial. Now check from the question, can we say that this is y? This is y, right? So we can say that dy by dx is what, 1 plus y or y plus 1, like replacing this with y, and we have a plus 1 over here, right? So from here I can see that the correct answer will be, that is A part. The next question is to differentiate this with respect to x. So let's say if I put y is equal to this. Now what I can observe that before finding differentiation, we should rationalize it. This way it can be simplified and will involve lesser working. So we have y as this, and we are going to rationalize. For rationalizing, clearly we will be multiplying, dividing with the numerator, but changing the middle sign. So this is what we did by reversing the sign of this and multiplied, divided. So check if I multiply the numerator, this is a minus a plus b and a plus b. So it can be written as a plus b whole square, that is x square plus 1 plus under root x square minus 1, the whole square. And below it's a plus b into a minus b into a plus b, which is a square minus b square. So it is a square minus b square. Next, we can apply the identity of a plus b whole square over here. So a square is the square of this, which is x square plus 1, plus b square is what? The square of this, which is x square minus 1. And then plus 2 times a into b. That means product of these two. So you can see that this can be written as what? X raised to the power 4 minus, right? Look into this. This is, I'm going to multiply this and this inside a root. So it should result to give you x raised to the power 4 minus 1, right? Below what we have, square of this is what? X square plus 1. And then we have a minus sign in between. So the square of this is minus x square and plus 1. Now this get cancelled. Now for further simplification, we can see y square plus y square is 2y square. And this 1 and minus 1 get cancelled. Plus 2 times whole under root y raised to the power 4 minus 1. And below we have 2. Yeah, the 2 can be taken common and can be written now as x square plus under root x raised to the power 4 minus 1. This 2 will get cancelled. Now here I find the differentiation, then it is x square differentiation is what? 2x, and root x differentiation is 1 over 2 root x. 1 over 2 root x. Then by chain rule, we are also going to find the differentiation of this. This is what? This should give you 4x raised to the power 3. Yeah, 1, 2 get cancelled from here, and whatever is the left is the final answer. This will be 2x cube over under root. Was that? This was x raised to the power 4, right? This is because it's x raised to the power 4. Okay, this is x raised to the power 4 minus 1. So this will be our final answer after differentiating.